Interpolation and set operations. Interpolation is a process of pixel replication. It is equivalent to a zero-order hold process which happens in sampling. Interpolation is quite similar to the multi-rate operation that happens for a signal to be upsampled. As a result, each pixel gets repeated on the scan lines, because of which the overall dimension of the image is increased to a large extent. Interpolation could be of different types. Mainly three types we would like to consider: linear, bilinear, and cubic. In the theoretical discussion, we will be considering mainly the linear interpolation. What is this linear interpolation? It is equivalent to fitting a straight line. The term linear tells us that it is linear, so it is equivalent to fitting a straight line. And the first step is zero interpolation, next one is averaging of columns, and the last step is averaging of rows. Let us go on with an example to see how these things happen. So we have been given an image H 2113, which means it has 2 rows and 2 columns. We have gone for a zero interlacing, which means we have added zeros. We have added zeros in between 2 and 1, and also between this 2 and 1, which means we have increased the dimensions, as can be seen here, from a 2 by 2 to a 4 by 4. Considering this, so this would be 2, 0, 1, 0. Between 2 and 1 also we want a 0, 0. So this 0 is here, and there is already one more 0. Beneath it there is one more 0. Here there is a 1. Beneath that, that is again a 0. And here there is a 0. There is one more 0 here. Again, between 1 and 3, we are inserting a 0 because already there is a 0 here. And similarly, after 3 also a 0 has been added. Finally, in the last row, we have added zeros similar to the second row. This is the first step, namely zero interlacing. Next, let us go on to see what happens when we do the averaging of columns. The value of the image is given. It is again a 4 by 4 image. It has been brought back just to see what it is. 2, 0, 1, 0. Second row full of zeros. The third row 1, 0, 3, 0. And last row again full of zeros. So how do we make the averaging of columns? The first column is going to be left as such. It is the original column, so nothing needs to be done for the first column. Second column is going to be the average of the first column and the third column, where we can observe that the third column is also a part of the original column because the original image was 2, 1, 1 and 3. So what happens for the second column is it is an average of 2 and 1. So it is 1.5. Here it is 0. So it is 0. Here it is 1 plus 3 by 2, which is 4 by 2, which is again 2. And here again it is 0. And considering the last column, we do not have any column after that. So it is an average of this column, the column preceding it, which means the third column. As a result, we will have 1 becomes 0.5, 0 becomes 0, and 3 becomes 1.5, 0 is retained as 0. So the second step is also over, where we have values given by values as shown in the step 2. The next step is averaging of zeros. When we go for the averaging of rows, when we go for the averaging of rows, the process is almost now clear. The first row and the third row are going to be retained, just like the first column and the third column were retained. As a result, what happens here is we have an average of 2 and 1, which means it is 1.5, an average of 1.5 and 2, that means 3.5. So the average is 1.5, 1 plus 3 by 2, which is 2, 1.5 plus 0.5. So here again the value is 1. And the last condition that we are going to consider is going to be, here we are just having the same values 1, 2, 3, 1.5. Here it is 1.5, here it is 1.75, here it is 2, and here it is 1.5 plus 0.5, so it is 1. The last row is going to be half of the previous row, that is the third row, 0.5. This is 1, this is 1.5, and this is 0.5. So we have got the final answer, which is going to be 2, 1.5, 1, 0.5, 1.5, 1.75, 2, 1, 1, 2, 3, 1.5, 0.5, 1, 1.5 and 0.75. So the rows have been averaged, the columns have been averaged, zero interpolation has also been taken place. As a result, the solution has been got. So what do we do? Next, let us go on for another example wherein we have been given an image 3, minus 1, 2 and 4. What happens to the linear interpolation solution? Can you just make an attempt? 3, minus 1, 2, 4. Since it is 3, minus 1, 2, 4, you are going to have values which is going to be, as can be seen, on first interpolation you will get 3, 0, minus 1, 0. Here there will be 0, 0, 0, 0, 2, 0, 4, 0 and last row will again have all zeros. Can you just calculate what would be the final solution? What would be the value of average columns, averaging of rows, and the final result is put here. Just you can check whether the same result has been got. Have you got the same solution?
Yes, ma'am.
Yes. So I think the concept is now okay. We know how to go about and find the interpolation given a simple image like 2 by 2 or 3 by 3. Larger images will be difficult because a lot of calculations will be involved. Next, we go on to the process of dilation and erosion. And in order to understand the process of dilation and erosion, we need to consider the image as a set, because set operations are to be applied for the image and the values of an image are going to be read as, this is going to be the 0th row, this is going to be the first row, this is going to be the second row, this is the 0th column, this is the first column and this is the second column. Where values are 1, we have highlighted it by red color. As a result, the values are at 0, 0. These are the two coordinates. First coordinate will be x, so this is going to be 0. 2, this is going to be the second value, and the last value is going to be 2, 2. This is how the image is being read. First row, column, and where ones are available, those values have been written. This is just to see how the binary image appears. Going in for the set of operations, mainly 4 set operations are considered here. The first one is a complement operation, which is similar to the NOT operation, which we have considered in the logical case, where each pixels are replaced by their inverted values, or 1 is replaced by 0 and vice versa. In the reflection case, if a pixel is having minus 5, it will be replaced by 5, and if it is having 5, it will be replaced by minus 5. This is the process of the reflection, and union is, it is going to be the combination of the elements present in A image and B image. As a result, usually we will see that after union, the number of elements will be more. Intersection, the elements which are common to both the images are going to be considered. When we say elements, it is actually the pixels, which means if the pixels are 0, 0 or 0, 1 in both images, then we will be considering that as the intersected value. So with this base, let us go on to see the first process, namely dilation. And generally, dilation and erosion are also known as morphological operations, because these are a set of operations which are basically based on set theory. They are used for extracting the boundaries, filling small holes, removing noise, And the basic requirement for such operations is that preferably the image should be in binary. Gray is also okay, but again gray will require more of computation because it requires a representation of 8-bit. And another requirement is that in the morphological operations, a mask is created. A mask would be dependent. If we talk about mask, which is now quite evident in the COVID era, it depends upon the size of your face. Similarly, the mask's size, that is the structuring element, will also depend upon what area you want to mask. If it is a square, you could use a square element. If it is a circular region which you want to mask or you want to remove, you may choose a structuring element which is going to be a circle or a square or a rectangle or triangle, whatever may be the shape. You could use a suitable shape. And usually the general shapes available are square, rectangle, circle, and even some form of ellipse. So by choosing a suitable structuring element, we might be able to remove unwanted holes in the image, or we would fill some holes in the image, and as has been mentioned here, we may be even able to extract boundaries. Suppose we want to extract this particular boundary, we know it is rectangle, so the structuring element used would be a rectangle. This is how the mask term is related to the structuring element. So we go on to the process of dilation, which is the first process which is described here, and as you can see, simple image is given whose size is 3 by 3 and it has got 3 rows and 3 columns. Here the first row is 0, 1, 2. The second row, the columns are 0, 1 and 2. The structuring element chosen is a simple structuring element. It is 1 and 1. So please note, when we say it is 1 and 1, I could have a structuring element like this. I could have it like this. I could have it at the last point. I could have it at any specific point. As a result, in addition to the structuring element, the coordinates are also specified so that it is specific where is the structuring element. If you see the structuring element, it is clear that it is available at the coordinates 0, 0. That means the first case. The next one is 0, 1, which means it is this case. So the structuring element is like this. We need not think about other shapes like, is it going to be vertical? Is it going to be horizontal towards the last row? Is it going to be vertical towards the last column? So on and so forth. The coordinates specify the location of the structuring element, which is also specific in this particular case. So the steps that are going to be considered for the dilation are, we consider where are the ones present. Let us first identify where the ones are present. Those coordinates, we will write them and we will call them as the coordinates of f. And to that, we will add the first coordinate of the structuring element. We will get a particular result. Again, we will take that result and add it with the next coordinate. We will keep on repeating until the number of all the coordinates are considered or the entire structuring element is covered. We have considered a simple structuring element which is just going to have 2 coordinates, or it is a 2 column 1 row structuring elements. So we have only 2 coordinates. As a result, this process will have only 2 steps. Let us go on to see the 2 steps more in detail. So the first step is finding out the values of f, which are 1. So this is going to be 0, 2. This is the first value. The next value is 1, 2. This is the second value. The next value is 2, 1. That is the next value. And the last value is 2, 2. So we have got this particular value. To this, we are going to add 0, 0. Luckily for us, the first coordinate is 0, 0. So there is no change when we add 0, 0 to the coordinates of f. As a result, the result remains the same as f. Let us proceed by going ahead by repeating it with other coordinates of the structuring element. Thereby, the next coordinate of the structuring element is 0, 1. Let us add 0, 1 to this particular step. What happens is, when we add 0, 1, this becomes 0, 3, this becomes 1, 3, 2, 1 becomes 2, 2, and this becomes 2, 3. So next what we have to do is we have added the coordinates to each point of f which was giving 1, and after that we are considering the union of step 1 and step 2. Luckily for us we have only 2 steps because only 2 coordinates are available here, and the union of these two is considered after removal of the repetition element, where the repetition element here is 2 by 2. Removal means we will write it only once, we will not repeat it twice. So actually we will be expecting a 8 element in the union, but we will see we are getting only 7 elements because 2 is a common element, or it is appearing in the structuring element S1 as well as in the structuring element S2, coordinate of S1 and S2. Next, let us go on for a simple example which is almost similar to the previous case. There are no changes with the coordinates except major changes, and the only thing that has been considered is that we are going to have 1, 1 as the solution. This solution that has been given is for the same problem which was given in the previous case, only with this particular coordinates. Here the example itself has been changed, and with this particular example, that is 0, 2, 1, 2, 2, 1 and 2, 2, we need to consider the solution of dilation after we apply coordinates 0, 0 and 1, 0, which means now the structuring element is like this. The previous structuring element was like this, that means it was horizontal. Now the present structuring element is vertical. Let us apply and see the solution. Can you just attempt it? The step for 1 will be the same, only step 2 you need to repeat. So to this, if you add 1, 0, what would be the solution? And you need to find the union. So are you getting the solution like this? 0, 2, 1, 2, 2, 1, 2, 2, 3, 1 and 3, 2. Have you got the same answer?
Yes, ma'am.
Okay. So hope the process of dilation is now clear. Maybe some more examples could be given as part of a tutorial or as a part of a quiz at a later stage. Can we proceed to the erosion? What is going to be the erosion? Erosion is going to be a basic process wherein what we are doing is almost similar to what was happening in the dilation case. Instead of addition, subtraction is going to take place, and instead of union, intersection is going to take place. So let us go on with the same case. Example is the same, which means the coordinates of f with 1 are identified, which means it is 0, 2. Here it is 1, 2. Here it is 2, 1. And here it is 2, 2. That is what is the first step. To this, we are going to subtract 0, 0. Luckily, since the coordinate is 0, 0, there is not going to be much change. So step 1 remains same for both erosion as well as for dilation. Next, we need to consider the second coordinate, which is 0, 1, which means we need to subtract from this 0, 1. So what happens is this becomes 0, 1, this becomes 1, 1, 2, 0 and 2, 1. In the previous case, we were considering all the elements and writing this only once, but here erosion is just considering the intersection. Hence, we will be considering the solution only as 2, 1. So the mathematics of dilation and erosion we have considered without going much into deep what is erosion and what is dilation. One more example is given for erosion. It is the same example. The coordinates alone are shifted. It is shifted to 1, 0. What is this? It's the same solution got 1, 2. Same solution has been got. Can we proceed? Yes, anybody is doing the problem? Got it? Am I audible?
Yes, ma'am, you are audible.
Have you got the solution as 1, 2?
Yes, ma'am.
Okay, so shall we proceed? So I think this example already, we have seen that what is the structuring element. Here you could see it's a square of 20 by 20. Here you could see that it is a rectangle of 40 by 10, and as a result, depending upon the structuring element, the size of the image or the size of the dilation or what you call the whitening part is either increasing or decreasing. So this is what is meant by choice of a structuring element. It could be either a square or it could be a rectangle. It is not necessary to use 20. We can use 10, we can use 50. Any value is okay. Similarly, here also, any value for the rectangle could also be used. Going on to the example which has been implemented in the university as part of the project for MTech. I'm just discussing that particular case. Vanilla, most of you are familiar, is a flavoring agent which is quite expensive, and the actual vanilla cultivation is really a lucrative process. So most of the farmers would like to cultivate vanilla and make some money. However, what happens is that when people go to buy the vanilla planting material, they are duped by giving wild species, which will not be so effective and so good as the original case. So image processing application was carried out to differentiate between the cultivated species and the wild species. Actually, two cultivated species are there and two wild species are there, which have been considered in this work. So how are we going to differentiate them? So the first process was using a camera, mobile camera only, with usual 5 MB resolution. The image was taken in background. I think after this, the green area was extracted. Noise needs to be removed. This is a process where we could apply morphological operations. So for operations we try, and after that we are calculating the geometrical parameters, which means we are calculating the area of the leaf, the perimeter of the leaf, etc., in order to find out whether from the we can say that this is the wild leaf and this is the cultivated species, which means a threshold could be fixed to identify these values. And based on that, some feature indices were arrived at, like rectangularity, perimeter by area ratio, things like that, which is based on the geometrical parameters, and they were used for classifying the species into the wild species and the cultivated species. The basic process of the green area extraction is the image is loaded. After getting the pixel, we are checking whether the green component is greater than red and blue component. If it is true, we are converting it to white pixel. Otherwise, we are converting it into black. This is the process of green area extraction. This is what has been done. And once the green area has been identified, the next thing is I would like to find out what is the length of the leaf, what is the perimeter of the leaf, what is the area of the leaf. Can I say that if the area of the leaf is, for example, 5, it is the cultivated species? In order to arrive at this, we would like to do some process. But when an excess green method has been done, you could see that the leaf which is originally smooth here has got some curves here. Similarly, some black spots have also entered inside the leaf. Small black spots they may be, but they will affect the geometrical parameter calculation to a large extent. So let us go on to see what are the processes that can be done to remove the noise. One particular example of a zoomed version of the leaf that was shown previously is considered here, and here you could see that lot of white spots have been appearing here. So what could be done? In order to remove the white spots, erosion has been carried out, and then dilation has also been carried out. And when we do erosion, we could see some black spots are there. That is why to remove the black spots, dilation has been carried out. But when dilation is being carried out, please see that there is an extra white spot here, which means the perimeter will turn out to be a larger value because of this particular elongation, because it will also consider that as part of the leaf. This will turn out to be error-sum, but however that was attempted at first, and to give you an introduction of this particular problem, this concept was discussed.